material science to engineer desirable properties in new materials. Now, in reality, material science doesn't work this way many times. So let me give you a very famous example. For those of you who haven't heard it, this is a wonderful example. So this comes from, there was a person, I believe in 1938, Plunkett, who was charged with collecting refrigerants for refrigerators. And in those days, the refrigerant that was being used was tetrafluoroethylene. And it was a gas. He was tasked with making a lot of it and collecting it all in a cylinder. And he did this. He was diligent, and he collected about 100 pounds of it or something. That sounds like a lot, but he collected a whole bunch of it in a cylinder. And then when the time came when his boss asked for the stuff, he opened up the cylinder and nothing came out. And he was annoyed, but then it turned out that the weight of the cylinder had not changed, so the stuff was still in the cylinder. So he cut open the cylinder and he found that the gas had turned to a solid. And that solid had some amazing properties. It was very smooth, and it was not sticky at all. And that's the solid that we now call Teflon, polytetrafluoroethylene, or PTFE, which now you can buy in Walmart for $6.99. That's where I got that picture from. I don't believe that this picture is true. This is a reenactment after the fact. But DuPont certainly made a lot of money off of this discovery, which nobody had planned for. Now, even though people don't plan for these discoveries, it is often the case that when you have some sort of new technology, that new technology allows you to make accidental discoveries like this. And let me tell you about one of these famous discoveries, which is related to some of my own research. And this is the discovery of superconductivity. So superconductivity, for those of you not familiar, is a property by which electrons can flow in a material without losing any energy whatsoever. So if you make a magnet with a superconductor, the electrons in a magnet will go round and round and round from now to the age of the universe. I should be careful in this building saying that sort of stuff. Usually my audience doesn't care about the age of the universe, but this audience does care about the age of the universe. It will stay for a long time, for longer than any of my students will take to get a PhD. So this phenomenon, that the resistance, what we call the resistance of a material, which tells you how much heat is given up when an electron goes through a material, the fact that the resistance goes to zero was discovered famously by Kamerlingh Onnes in also 1908. And in his case, what enabled him to make this discovery was the fact that he had learned how to make a beautiful dewar in order to store liquid helium. So a dewar is very much like a glass vacuum flask. I'm sure all of you have used these to have hot tea or coffee. Kamerlingh Onnes, he learned how to liquefy helium about 1901 or something. But his problem was that he would make liquid helium, and the liquid helium would just boil away very quickly, and he had no way to store this liquid helium. And after a few years, he learned how to make beautiful dewars. So this is a design of his glass dewar, where he could keep the liquid helium around for a day and actually do some experiments with it. And so in 1908, he filled this dewar with liquid helium. And for reasons that are not completely clear, he decided to put a piece of mercury into it and measure its resistance. Now, there's some controversy about why exactly he decided to do this. There's even suggestions that somebody else actually did the experiment and Kamerlingh Onnes took the credit for it, which wouldn't be surprising, but regardless. So here is the data from his lab notebook, very famous data. What he found was that if you measure the resistance of mercury, then the resistance of the mercury went along like this very nicely, and at some temperature, which was 4.2 degrees Kelvin, 4.2 degrees above absolute zero, the resistance of mercury just abruptly vanished and went to zero. And this was amazing. One would never have predicted this. But in this case, this particular thing was enabled by the fact that he could make this beautiful dewar and actually put things in it and see whether they became superconducting or not. Now, of course, once discoveries like this are made, it then becomes much easier for people to follow this on and do research after the fact. So once you discover that mercury is a superconductor, it doesn't take a lot of genius to say I should throw everything in liquid.